Welcome to this explainer. Okay, let's dive right into this. Today, we are looking at two absolute giants of the computing world, Unix and Linux. If you use a computer, a smartphone, or honestly, even just browse the internet, your daily life is quietly but heavily shaped by the architecture of these operating systems running constantly behind the scenes. We're going to decode the fascinating history, the under-the-hood architecture, and the intense business models that define the original computing brain, Unix, and its everywhere you look open source successor, Linux. So to kick things off, let's address a massive misconception right out of the gate. Are Unix and Linux the exact same operating system? Because they share similar commands, a similar structural philosophy, and similar environments, people often use the names totally interchangeably. You'll constantly hear Linux referred to as a Unix-like operating system. But as we're about to see, structurally, historically, and legally, they are distinct entities with very, very different trajectories. On one side of the divide, we have the territory of Unix. Born back in the 1970s, it became the proprietary brain of those massive legacy enterprise mainframes and high-end corporate servers. On the other side, we've got Linux, and you'll find it practically everywhere today, powering modern smartphones like Android, running the vast majority of our cloud servers, and yeah, even operating smart refrigerators. To understand exactly how we ended up with this stark split in territories, we really need to go back to the beginning. Section 1. The birth of Unix, laying the computing blueprint. Let's trace the timeline here real quick. In 1969, Unix development officially started at AT&T Bell Labs by a brilliant team that included Ken Thompson and Dennis Ritchie. Initially, it was just meant to be a convenient platform for programmers, but the real game changer happened in 1973. Unix was completely rewritten in the C programming language. Now, why does that matter? Well, before this, operating systems were heavily tied to specific clunky hardware. Rewriting Unix in C made it the very first truly portable operating system, meaning it could suddenly run on numerous different hardware platforms. Fast forward a bit to 1991, and a student named Linus Torvalds releases the Linux kernel, launching a massive, massive disruption. Section 2, the Linux Revolution. A free clone emerges. By the late 80s and early 90s, Unix had become highly commercialized and, quite frankly, very expensive. The tech world desperately needed a free alternative that still worked, like Unix. Enter Linux. It's essentially a clone built entirely from scratch to meet what they call POSIX standards, but, and this is absolutely crucial, without inheriting a single line of original proprietary Unix code. Linus Torvalds, working alongside the broader GNU project created by Richard Stallman, helped build a fresh, community-driven system that behaved exactly like Unix without any of the legal or financial baggage. Section 3. Architecture under the hood. The monolithic engines. Despite their different origins, both Unix and Linux share a foundational design philosophy. They both use what's known as a monolithic kernel. Think of this as a large, single executable image running entirely in a single address space. All the core kernel services, your memory management, your process scheduling, your hardware drivers, they all exist under this one large roof, which allows them to invoke functions directly with each other. Proponents of this model love it for its undeniable simplicity and its incredibly high performance. If we picture this monolithic structure, it's like a set of concentric rings. Hardware sits right at the absolute core, enveloped directly by the kernel, which is busy managing memory and process scheduling. Wrapping around that is the shell, processing all the user and system commands, which in turn supports the outermost ring, your application programs like database systems or web servers. Diving even deeper into the kernel itself, we can really see those internal subsystem interactions. You have the system call interface, which basically bridges the gap between user space programs and the kernel level. Below that, the file system and the process control subsystem are managing resources, all sitting right on top of the hardware control layer. But here is where Linux pulled a very clever trick. While Linux is a monolithic kernel, it supports the dynamic loading of kernel modules. And guys, this is a massive game changer. It means Linux can load and unload new hardware drivers or features on the fly without ever needing to reboot the system. That gives it incredible flexibility compared to the older, traditional Unix variants. Section 4, Licensing and Cost Models. The business battle. Let's use a car analogy to really understand this split. Think of Unix as a fancy, highly specialized, expensive custom car. You have to pay a massive premium for it, and it's generally restricted to giant companies with deep pockets who need it for very specific, heavy-duty tasks. Linux, on the other hand, it's like a free, completely customizable car. Literally anyone in the world can download it, install it, open up the hood to look at the engine blueprints, and modify it without paying a single cent. Breaking down the actual business models here. Unix operates on proprietary licenses with steep fees. It's entirely vendor-driven by corporate giants like IBM, HP, and Oracle, who create their own dedicated distributions like AIX, HPUX, and Solaris. Conversely, Linux thrives on the open-source GPL. It is completely 100% free. Its development is driven by a massive global network of community contributors, and that's resulted in incredibly popular, adaptable frameworks you've probably heard of, like Ubuntu, Debian, and the enterprise-focused Red Hat. Section 5. Real-world use cases. Where do they dominate? The numbers here paint a really striking picture of our modern tech landscape. Get this. Linux powers over 90% of the top 1 million cloud servers. 90%! It is the undisputed backbone of the internet as we know it today. But hey, Unix is far from dead. It still drives around 69.5% of mission-critical legacy systems. It retains a fierce stronghold in environments where long-term stability and specific hardware compliance are absolutely 100% non-negotiable. When we break that down by industry, you can see the territories clearly mapped out. If you are on an Android right now, using Google Cloud, or working with IoT devices, you are relying on Linux. It completely dominates cloud-native development, like AWS, mobile systems, and cybersecurity platforms, like Kali Linux. Unix, meanwhile, remains the trusted, heavy-duty engine for mainframes, high-security banking transactions, backbone network routing for telecommunications, and high-end scientific research. So, Linux is everywhere and highly flexible. Unix is specialized and incredibly robust. As we wrap up this analysis, I really want to bring it full circle. Dennis Ritchie, the co-creator of the original Unix, reflected on this dynamic back in 1999. He said, Linux seems to be among the healthiest of the direct Unix derivatives. Despite the intense competition, there's a deep underlying respect there. Linux didn't just replace Unix, it stood on the shoulders of giants. It carried that original Unix philosophy of modular, file-based, tool-oriented computing right into the modern open-source era. So I want to leave you with a final thought to ponder. As cloud computing, edge networks, and AI just continue to evolve at breakneck speeds, will the original titan, Unix, eventually fade out entirely? Or will those massive mission-critical legacy systems, the global banks, the telecom networks, will they always require that highly specialized proprietary foundation that only Unix provides? It's a fascinating conflict of computing architecture. Thanks for joining me on this explainer, and keep exploring the systems that run our world.